In this video, we'll deal with types of orbitals. The first one is the s orbital. The shape of the s orbital is like this. From this, we can infer that the shape is spherical. In fact, it has got a spherical electron density, and the electron density is equal in all directions. The orbital is non-directional. That means we cannot say that the electron density is directed along a particular axis, say x, y, or z axis. It's not. And we have zero nodal plane in the s orbital. Nodal plane means the plane along which the probability of finding an electron is zero. We see that electron density is seen in all directions equally. So we have got zero nodal plane. Now it is zeroed with respect to phase sign. Zeroed means simply symmetrical with respect to phase sign. In the second, we have p orbital. P orbital is along the axis, and it has got one nodal plane, and it is unzeroed or unsymmetrical with respect to phase sign. So this is the px orbital. In the px orbital, we see that the orbital is directed along the x-axis, and we have the plus sign. The phase sign is plus here and the phase sign is minus here, and this is the nodal plane. We see that it has got one nodal plane as was told here, and the orbital is directed along the axis as was told here, and it is unzeroed or unsymmetrical with respect to phase sign. That means it has plus and this is minus, so it is unsymmetrical with respect to the phase sign. Similar explanation for the py and the pz. Now we can, it might be asked sometime that what is the name of the nodal plane. So we can see that the nodal plane that is perpendicular to the x-axis will be yz. So in this case, in the px we have yz as the nodal plane, yz. In the py we have xz as the nodal plane, and for the pz we have xy as the nodal plane. Finally, the d orbital. In the d orbital we have two different kind of orbitals. In the first kind, the orbitals are in the plane between the axis, and the second kind, the orbitals are directed along any axis. Now among the first kind, we have three different types of orbitals, that is dxy, dxz, and dyz. In the dxy, for example, the orbitals are in the xy plane and between the x and the y axis. In the dxz, the orbitals are in the xz plane between the z and the x axis, and similar explanation for the dyz orbital. We see that we have two nodal planes in the dxy, dxz, and dyz orbitals. In the dxy, the names of the nodal planes are this one, this would be the xz plane, and this one, this would be the yz plane. You can imagine this is the this is the z axis, and the plane can be like this. This would be an xz plane, and for this another nodal plane would be like this, and this would be the yz plane. Similar explanation for the dxz and dyz orbitals. Now dx squared y square orbital. In the dx squared y square orbital, the orbitals are directed along the x and the y axis. Here we have again we again have two nodal planes, and they are at 45 degrees to this x axis and y axis. In fact, 45 degrees to the xz and the yz plane. This is the z axis, so the xz plane would be like this, and this is the y axis, so yz plane would be like this. So we can see that they are at 45 degrees to these two planes. Now finally, the dz square orbital. In the dz square, the orbital is directed along the z axis, and here we do not have any nodal plane. In fact, we have a nodal cone. You can see the shape forming here. The shape is of the cone. So we say that it has got one nodal cone and zero nodal plane. So this was it on the topic types of orbitals, and in next video we will deal with overlapping theory.